Oh, am I locked up? There we go. Okay, listen up. Is this the one we left off on? Listen up. Did I miss a couple? Okay. Wait, so we did the carbon dioxide and water one. We did this one.
We did the ethane one too.
We're just on additional.
Yeah, this is the ethane. Hey, come on, what's going on? Why does this take so long? Okay, here we go. All right. As long as you're paying attention, I don't care. I mean, it's nice to be able to look back at your notes later. It's the paying attention thing. That's the big deal. All right. You know what? I need an additional slide here. So hang on just a second. Let me give myself a slide so I can write these down. Well, this is a pain. Okay, listen up. So again, we're just going to go through a couple more of these just to get you some additional practice together as a class. And then I'm going to give you a couple of worksheets, and they're fairly long. They'll take you a while. But you need to use your class time to practice these because this is the... Yeah. So this is the time that you can actually ask me questions if you're confused about things. What's that?
We're not learning anymore. We're just going over.
No, this is kind of just reinforcing what we learned yesterday. Okay.
So and then the new packet that we're going to get reinforcing?
Well, it's not a new packet. It's homework problems. Yeah. Yep.
Okay, good.
All right. So next one here, magnesium and hydrochloric acid react to produce magnesium chloride and hydrogen. Okay. So we need to write the formula equation for this first. Okay. So magnesium and hydrochloric acid.
I didn't know hydrochloric.
Well, which is fine. So magnesium is just Mg, okay? That's not one of the diatomic molecules, so we don't have to worry about Mg2 or anything like that, all right? It's just Mg plus hydrochloric acid. That one we talked about yesterday. Good. But again, I don't expect you to remember that yet. We haven't talked about how to name acids, so I will give you the formula for any acids. Okay? That's going to react to form magnesium chloride. All right, some of you are getting right back on the bike here with these ionic compounds. That's good. Yeah, that's impressive. All right, so Mg... Mg is a 2 plus, right? Cl is a 1 minus. You crisscross. That's going to give you MgCl2. Plus hydrogen gas. H2. Good.
Are you impressed with me, Mr.
Yes, I am. Oh, okay. I'm impressed with your gas then.
I did that.
All right, so now we need to balance this one. This one's not going to be too bad, I don't think. Is there anything that I need to do last here? Looks fine. Okay, so let's review that. Listen up. But just in case there are some people who don't. So I need to look and see if there are any of these that are on both sides of the equation at the same time. That was a dumb thing to say. Sorry. Let me try that again. Okay. Anything that was like magnesium, if it's in both formulas on the reactant side, or if it's in both formulas on the product side, I would want to save that one for the end. Okay. But we don't have anything like that here. Magnesium is only in one place on the reactant side, only in one place on the product side. Same thing with hydrogen and chlorine. So it doesn't really matter what order you do this in. I don't know why, but I always tend to do the metals first and then save hydrogen for last if it doesn't matter. But again, I don't think it's going to make a difference for you which way you balance this, okay? How many magnesiums on the left? And on the right? 1. How many chlorines on the left? 1. On the right? 2. How many hydrogens on the left? 1. How many on the right? Well, this is really easy, isn't it? What do I do here? Oh my goodness. Okay, so 2 HCl, that changes that to a 2, that changes that to a 2, and we're done.
Wait, explain it to me, Marco.
Explain what to you?
How'd you get all of them proceeded to?
Ooh, okay, we're probably going to have to talk about that at some point later. What's that? This one down here? Okay, because I put the 2 in front of the H and the Cl, right? Well, there's no subscripts there, right? So if this was a 2 or something like that, then I'd take 2 times 2. That would give me 4. All right, so that's that one. Again, let me just let me reinforce this. This is all I care about, okay? You don't have to do this. This is just, the tally part is just for you to keep track. On the really complicated ones, it's a good idea, okay? On this one, you probably could have looked at that and said, oh, I need to put a 2 in front of that HCl, and that will give me a balanced equation, all right? If you start getting comfortable enough with these that you can just figure out what coefficients need to go where, that's fine with me, okay? Because I'm not going to look at your tallies. All I'm going to look at is, do you have the right coefficients in front of each of the formulas? That's the answer, the part that I circled. All right? Okay, so let me erase this, and then we'll do the next one. Aqueous nitric acid reacts with solid magnesium hydroxide to produce aqueous magnesium nitrate and water. Tell you what, let's do states of matter on this one just for fun, because it'll be fun. Nitric acid. That's not one that you're going to know off the top of your head. We are going to learn the naming rules for acids later in the year. But for now, nitric acid is HNO3. All right? Yes? Okay, what do they mean by aqueous? Do you remember that from yesterday? It means it's dissolved in water, okay? So that's actually a symbol. If we're going to label our states of matter, you'd just put AQ in parentheses after it. Yeah, we're going to do that for this one, just so you have some practice with the states of matter.
I don't get it.
You don't get why we put an AQ there? Okay, if you look back on your notes, like on the first or second page, I gave you the possible states of matter that you can have in the equation. One of them is aqueous. Do you see it?
Oh, yeah.
Okay. So the abbreviation for aqueous is just AQ. And yeah, and all that's doing is showing what state of matter it's in when it reacts. All right? Okay, so HNO3, nitric acid, plus solid magnesium hydroxide. Magnesium hydroxide, that one's a little bit tougher.
I just said MgOH.
MgOH2, okay. Now, for those of you who are not sure where that came from, Mg is a 2 plus. What's hydroxide again?
4 minus.
OH. Just 1 minus, okay. Because it's on your polyatomic ion chart. Yeah. Which, again, that would be a good thing to probably have out while you're doing the balancing later today. So you crisscross, you end up with Mg. Make sure you put the OH in parentheses, okay? And it says that it's solid MgOH2, right? So you put the S right there. I need to make my arrow little. I've taken up too much space with the left side of this equation. Whoops. To produce aqueous magnesium nitrate. All right, this is a tough one too. Magnesium nitrate. We know magnesium is 2 plus, but it's nitrate, not nitride. Good. So you have to look on your polyatomic ion chart. It's NO3 1 minus. Okay. So then the formula would be two, right? And that's aqueous, isn't that what they say? Yep. Yeah, I'm seriously running out of room here. So that's AQ plus water. This is unfortunate.
Yeah, I'm running out of room.
Sorry. Now H2O is a liquid at room temperature, right? So we would put an L in parentheses.
Oh, I can substitute by the ND.
Why did I put it to where?
Why don't you put it by the ND?
Because you crisscross, remember?
Yeah, but when you crisscross. Oh, that's what I have.
Yeah, it's a 1 minus. Yep. Okay, so now we need to balance, and sorry, this is not nice and neat. Okay, let's talk about what we can and can't do here when we're tallying, all right? We can keep the NO3 together, right? Because we've got NO3 on this side, we've got NO3 on this side. Can we keep the OH together? Unfortunately not, because we don't have any OH on the other side of the equation. Now, you kind of do with the H2O, but we're not going to worry about that. We're going to have to balance those separately, okay? So I've got magnesium. I'll start with that because that's only in one place on each side, right? Then NO3 probably is my next one that I want to deal with because that's only in one place on each side. And then I'm going to have to do the oxygen and the hydrogen separately here, okay? Which one of those should I put last? Good. So some of you are seeing it, right? There's hydrogen in two places on the left side, right? There's one here in front of the HNO3, and then there's a couple in the OH, all right? So we want to put oxygen first. Hydrogen needs to be last here. I'm telling you, if you do this in the right order with your tallies, they will take care of themselves a lot of the time, okay?
How do you know which one was last?
Because see how there's a hydrogen here and a hydrogen here on the same side of the equation? Because it's split up into two places, that one's going to be complicated to balance, so we save it for the end, okay? The oxygen is only in one of the formulas on the left and only one of the formulas on the right, okay? The NO3 is only in one of the formulas on the left, only one on the right, so. All right, so how many magnesium on the left?
One.
On the right? One. NO3, we've got one on the left, two on the right. Stop me if you're confused, because there's a two outside the parentheses. Okay, oxygen on the left. Now, here's where you have to be a little careful. We don't count this because we already counted it with the NO3. Does that make sense? So just two. And how many on the right side? Again, remember, we don't count the oxygen in the NO3. Just one. And then hydrogen on the left. Be careful here. One here. Two here. So that 1 and 2 is 5. Yes. So 3 on this side. And then how many on the right side? Just 2. Okay. Now this one looks like it could end up being one of those kind of complicated ones, doesn't it? Let's find out. First thing we need to balance is NO3. You want to start at the top, work your way down. The magnesium's already balanced, so let's go to the NO3. Okay. Yeah. So I need to put a 2 in front of the HNO3. Does everybody see that? Put a 2 here. That's going to change my NO3. Now I've got 2 of those. But it changed something else. I put a 2 here in front of, okay, so now I've got 2 hydrogens here, but then we also still have 2 over here. So it's going to be 4 now. Everybody okay with that? No, not yet. But this one's actually not going to be that hard. Because now what can we do? If to balance the oxygens, what do we need to do? 2 in front of the H2O. That's going to give you 2 here, but I also changed my hydrogen to 4. Oh, that's nice. We're done. See, that one looked bad, but it wasn't so bad. What's that? Okay. Yeah, that's fine. I mean, we're going to have lots of time to practice it right now, too. So. Okay. Let me see if there's anything special about any of the rest of these. Calcium metal with water to form calcium hydroxide and hydrogen gas. And then you've just got a bunch more practice here. I'm trying to see if any of these are going to be weird. sorry, there's more notes today than I thought. So this one we'll skip because I think you guys can do this. A and B on this one we'll skip, but I want to do C. All right?
It's gonna be nasty.
I feel like it is. I don't remember for sure, but all right. In a blast furnace, the reaction between solid iron 3 oxide and carbon monoxide produces solid iron and carbon dioxide gas. Okay, so wait, is that it?
So we need the I3.
Solid iron 3. No, okay, that's not it. You know what? I'm going to use this slide because it's kind of blank. Just ignore this for... What are you doing? There we go. Just ignore this for now. Okay?
What's the right answer?
No, that's not. That's a different problem. Okay, so the reaction between solid iron 3 oxide. So we got to figure out the formula for iron 3 oxide.
So it's I.
Well, iron's Fe. So Fe, what charge does the Fe have? How do I know it has a 3 plus? Roman numeral. Okay? And then the oxygen has what charge? Everybody okay with 2 minus? Yeah? In group 6. Okay, so then we crisscross those. It's going to be Fe2O3. Excuse me, Fe2O3. Okay? That's reacting with... Yeah, I'm not worried about the states of matter on this one. Carbon monoxide. What is that? CO. Yep, mono means 1. Good. And solid iron. It produces solid iron, so that's one of our products. Fe, just by itself. And carbon dioxide gas. CO2. All right. So here we go. Let's balance this thing. Okay. Tell me which one's going to go last. Just right off the bat. Which one is... Yeah, oxygen is everywhere here, right? Okay, it's in these 2 on this side and then 1 on this side. So we want to save oxygen for last. So iron's first, that's fine. You could do carbon first too. I don't think it really matters between those 2. But oxygen needs to go last. So 2 irons on the left, 1 on the right. 1 carbon on the left, 1 on the right. How many oxygens on the left? Everybody see that? 3 here, and then add it to that 1, so there's 4. And then on the right, we've got 2. I could be wrong. Maybe this one's really easy, but we'll find out in a second. Okay. So, first thing I need to do is balance the iron, right? Yeah, that's easy. So put a 2 in front of the Fe. That doesn't change anything else. So carbon's okay, so now we need to balance the oxygen.
Put a 2 in front of the O.
The CO2.
2 in front of the CO2. Yeah, this might be nasty after all. So there's a 4 here, but we changed our carbon to a 2. Oh, okay. So then if we put a 2 in front of our CO, which is what we need to do, that's going to mess up our oxygen over here, right? So put a 2 here. Now how many oxygens do I have?
That's what I get confused about.
Okay. How many oxygens do you have right here in this formula? 2, right? And then you have 3 over here, so you add those 2 together. Just think where there's a plus sign, you actually do add them. Maybe that'll help, okay? So you've got 5 now on this side. Ugh. Okay. So we've got a problem, right? We've got that odd even situation that I talked to you about the other day, right? Okay, but hang on, you need to know what to double. That's the most important thing here, okay? Which one is causing the problem at the moment? Which one is causing the number to be odd on the left side? I don't think that's causing it to be odd, is it? That's the one that has the odd subscript, isn't it?
How do you look at?
Yeah. Okay. So because the Fe2O3, that's the one that's causing it to be odd. Because I can change this subscript to be, 3 or 4 or whatever, but that's not really going to help me because that's going to change my carbon also. let's change the one that has an odd subscript. Okay? So put a 2 here. Oh man, we just changed a bunch of stuff. So now how many oxygens do I have?
You have 2, 5, 7, 8.
Hopefully not an odd number still. Otherwise what I did had no purpose, right? So 2 times 3 is 6, right?
Yeah.
There's 6 here and then 2 on the carbon monoxide, so that's 8. But I also changed my iron, didn't I? Now that's not a big deal because the iron's all by itself over here, so I can put whatever number I want in front of the iron. So let's just change that to a 4. And this, again, comes back to my recommendation that you use pencil on these so that you can erase subscripts if you need to. But now we got to change the carbon. Wait. We got to change the oxygen, sorry. So what am I going to do on the right side to the oxygen? I've got to put a 4 in front of that CO2. Yep, I knew this one was nasty. So that's 8. So now I've got 4 carbons, right?
Yeah, so you'll just have to put it's not like the game.
Now I got to put a 4 in front of here. 4 in front of here. So that's going to change it to a, well, 10 oxygens, 4 carbons, right?
So now we have to change things. And it's going to keep on changing. I don't think this has an ending. Yeah, this doesn't. Like, I think it's no solution. Yeah.
No, there aren't any that are no solution.
No, there's always a I think Are you going to make us go on and on, or are you going to let us practice?
Yeah, I'll probably let you practice.
Yeah.
And I'll pause the video and I'll try and figure this one out.
Are you going to do the significance equation?
We'll talk about that tomorrow. Because you don't need it for your quiz, or we'll talk about it Monday because you don't need it for your quiz on Monday. Okay, so we'll finish it up then. Okay, so I'm going to talk about that last one real quick. Just in case there's anyone who wants to figure this out. There are certain times when my little procedure doesn't actually work. And this is one of those times. The iron 3 oxide, carbon monoxide, iron and carbon dioxide gas. So that one, the formula was written correctly for that one. It's supposed to be Fe2O3 plus CO yields Fe plus CO2. Okay? So on this one, if you get in a situation where you're just stuck and my system's not working, every once in a while you can come across something like that. I guess actually we can kind of do this the way that we were doing it. But we would have to change one thing at the end. So we've got a 2 here, a 1 here, 1 and 1, 4 and 2. Okay? Put a 2 here. We put a 2 here. At that point it changes your carbon to 2 on this side, so you put 2 here. Okay. Which changes your oxygens to 5. Okay. So you do have an odd even situation, but the other way that you can change it to make it even is you can change the coefficient on the CO. Okay, so I said not to do that at first. If the other way is not working, if you're trying to change this coefficient on the Fe2O3 and that doesn't work, then we can try changing the coefficient on the CO to make it even. And the easiest way to do that is to change this from a 2 to a 3, because then now you've got 6 oxygens on this side. Okay, that changes your carbons to 3, and then you can change your CO2 coefficient over here to a 3. To a 3. So then that's going to give you, I need to read, I know I'm good on that. So that gives you 6 oxygens over here, that gives you 3 carbons here. Okay, so then everything's balanced. Alright, just wanted to show that to you in case you are interested in the solution of that one. You won't typically see ones that are that tough, but every once in a while if you're using my system and it breaks down, you're just going to have to Mess with it, see if it works.